Hypotonic is two solutions with the same osmotic pressure across a semi-permeable membrane. An example of this is your blood in your blood vessels. This is a visual example of an isotonic solution. The concentration of H2O molecules is equivalent both inside and outside of the cell. This is how our blood cells normally function. The concentration of H2O both inside the erythrocyte and outside in the plasma are at equilibrium.
Hypotonic is any solution that has lower osmotic pressure than another solution. In a hypotonic solution, the total molar concentration of all dissolved solid particles is less than that of another solution or less than that of a cell. If concentrations of dissolved solids are less outside of the cell than inside, the concentration of water inside is greater. When a cell is exposed to such hypertonic conditions, there is a net water movement inside the cell. If excess water is not removed from the cell, then it will burst.
All right, next we're going to talk about a hypertonic solution. That is when the molar concentration of the dissolved solute particles is greater than the concentration of the solvent. A good example would be salt water, which has a high solute concentration because it contains salt. In this situation, if the concentration of solutes is greater than that inside the cell, then the solutes inside the cell, it will cause water to leave from inside the cell and go outwards, causing the cell to shrink. A good example would be in an animal cell, where the concentration outside of the cell is greater than that inside the cell, and that is going to cause the H2O molecules to leave the cell, which will cause the cell to shrivel and shrink. A good example of a dehydrated cell. All right, so I'm going to explain the differences between a hypotonic and a hypotonic. Excuse me, hypertonic. All right, so whenever you're talking about a hypertonic solution, remember that hypertonic cannot be by itself. That basically meaning if I were to say the glucose solution